So it's gonna take super long?
No, it shouldn't.
Oh, I was like, oh, yeah.
Prepare for the ride of your life.
All right, 3.3, logarithmic functions and their graphs. So logarithmic functions, not the graphs.
Yeah.
Graphs are just nasty. Is there like, what's the point, you know?
That's the thing. Next year I have to do a lot more with graphs because there's a lot you can't use your calculator for. The thing. All right, so I'm gonna do a quick refresher. So if you have log base b of n, it's supposed to be equal to p, and base b raised to power p is equal to number n. If you wanted to go back and forth between them, you would do, so you have a log, you want exponential to solve it. It would be b raised to the p is equal to n. So it makes an e. You have an exponential and you need a log to solve it. It's the ones we were doing yesterday at the end with those word problems, which is why I said I wish they taught this section first, and I really need to remember to flip them, but next year it might not even matter. We have log base b, some number n, is equal to some power p is how it was always taught to me, but it makes an L.
Ish. Yeah.
It's an L, I just didn't close.
Yeah.
A log where there's no like there's no b written there, you assume is log base 10. It's a common log, okay, which is the log button on your calculator. The one she can actually use, yes. The log, if it says log base e, but it'll very rarely be written that way, is a natural log. It's also what ln is a natural log. So there's actually an ln button on your calculator. That's what that's for. Those properties of logs, I would know those. They're helpful. All right, so these pretty much are all just evaluate the logarithmic expression without using a calculator. So, yeah, no calculators for these. So, number 2, log base 6 of 1. Now, these are not going to automatically say they're equal to something like this. So, I always do this. It's equal to... So you're saying, basically then, so you have a log, we're going to use an exponential to solve it. 6 raised to the x is equal to 1. Yeah. So 6 raised to what power equals 1? 0. So x equals 0. Now, that one is one that's a property.
So then would we say it's a property?
You don't have to, but I'm saying you wouldn't have had to do this if you just recognized that it was a property. Yeah, it's your property number 1. Log base b of 1 is equal to 0.
So the properties are just like to help you. You don't have to like state.
Right, yeah, you don't have to state them. It's more just like it makes it easier to, yeah. For log base 3 of 81, and then, like I said, I always write the equals x part. Now, there's a couple ways you could do this. I'm going to do the E way first, and then I'm going to show you the other way that uses one of the properties. So, oops, wrong color. We're going to have 3 raised to the x is equal to 81. So we're thinking 3 raised to what power is equal to 81? Okay, 3 times 3 is?
9.
Times 3 is?
27.
Times 3 is?
81.
So to the 4th power. So x is equal to 4.
I was guessing. I didn't really know.
Now, the other way that we could have rewritten this so that we could use property 3 is log base 3 of, because this is something that 3 is like, you can raise it to or whatever, is 3 to the 4th. Property says that then when those two things, those two things cancel, your answer is just whatever the power is that it's being raised to.
Okay.
So I'm just going to note that that's from property 3, so that if you wanted to understand where that's coming from, you have it.
Interesting. Okay.
6. Log base 6 of 1 over the 5th root of 36 is equal to x.
I've never seen a 5th root before, and I hope I never again.
Alright, so this one's one you're going to just really have to track with me for a second, because I'm basically trying to rewrite it like I did this. But I'm going to do the E method and show it to you. Okay, so we have 6 raised to the x is equal to the 1 over the 5th root of 36. So basically, I want both sides to end up with a base of 6. So I want to rewrite the right side in terms of 6 raised to some power. Okay? Now, a square root of a power, or like a root of a power, or, oh my goodness, a root of a number can be rewritten as a power. Okay, as a fraction. So I can rewrite this as 1 over 36 to the 1/5. Okay, but notice that this is 6 to the x, so I need the 36 to be on top. So if I want to move it up, what do I have to do to move it? What do I have to do to the power to move it? Make it negative. So 6 to the x is equal to 36 to the negative 1/5. 36 is 6 to what power? 2. So 6x is equal to 6 to the negative 2/5. So x is equal to the negative 2/5. Now, you could have chosen to rewrite this, okay, right away to use this property. But I think it's easier to see it like this. And honestly, that's probably the most confusing one of them all. So if you're like thoroughly confused, don't stress over that one too much.
You said this section is short, like example-wise?
Well, I mean, there's a lot of examples, but it's not hard.
Oh.
They're fast examples, if that makes sense. 8. Log of 10,000.
Okay.
Okay, you do you.
So what base is this?
Oh, wait.
It's not written, so it has to be what?
I wrote it in the base.
It has to be
1. Oh wait, 0.
Talked about this right when we started. 10.
Oh,
So there's an imaginary 10 that's there, okay? So this is the problem. A lot of times if people go to draw the E, they forget that it was a 10 to start with. So it's 10 raised to what power?
10 raised to the x power.
So 10,000 is 10 to what power?
100. Wait,
What?
that's so wrong. Give me a
10 times 10 times 10 times 10 times 10. Josh wants to multiply them 100 times.
Wait.
Is it 4?
Yes. Okay, however many zeros it has
Count the
is.
zeros.
I accidentally multiplied.
So x equals 4.
100.
Sorry.
It's okay. I was just confused.
I just multiplied 10 by 100. I was like,
Alright, log of 10 to the negative 4. I'm not going to do the E on this one because this one's property that we've talked about already.
no. 10 negative 4.
It's one of those 4 properties.
So base 10 right? I don't know. I haven't done that.
It's one of the 4 basic properties.
Well, I don't understand these 4 basic properties.
Well, look at which one it could look like. What base is on this?
10.
10. Okay, so look at that in terms of what you have on this property page.
Ooh, it's property 3.
So what is the answer?
Why? Wait, I don't know.
Well, it can't be y. There's not a y in our
negative
problem.
4.
Negative 4. Okay, because these 2 things cancel each
I
other.
see which one.
So that one is property 3 again.
I see now.
All right, moving into some natural logs. Number 14, the ln of e to the negative 4. This one is also a property. What base does ln represent? It's a natural log. What base does it represent?
E.
E. So you have log base e of e to the negative 4.
So it's negative 4?
Negative 4.
Can't just do that like that.
All right, 16.
Messing with my head.
ln of 1. This one's also a property.
Okay, so it has a base of E, right?
Yep.
So 0.
Now, don't write this.
Oh, don't. Thanks.
Why not?
Because that's not accurate. If you're going to do that, you need to do this. But a natural log is a log base e.
Oh.
So by putting another e on it, it's not right.
Oh, does that apply for 14 as well?
Yes.
Oh, okay.
Anything that's a natural log. ln is equal to that.
Okay.
So if you need to rewrite it this way.
Okay.
Once you get used to it, it's just going to naturally just happen. No pun intended. All right, I'm going to do 18 because it's similar to this weird one that we had up here, wherever it went, this one,
Fraction.
but with ln. So ln of 1 over the square root of e to the 7th. But I'm going to do this one a little bit different. I'm going to do it the way where I just rewrite it in here because then it'll allow you to use a property.
Okay.
So the square root allows me to rewrite this how?
As a power. So 1 to the 1 over 7. Wait, that's so wrong.
Square root. So what power is that?
E base of power of 1 over 7.
1. 7 over 1.
Ignore the 7.
Oh.
The 7's inside. I need the square root.
1 over 1.
Okay, so this one up here, it was a 5th root, so we said it was 1/5. So a square root would be
1 over 2.
1/2.
Oh.
So I have
Oh.
the ln of 1 over. Now it's already being raised to the 7th power, so it's going to be e to the 7 over 2. But I need to move it to the top. How do I do that? Make it negative. So ln of e to the negative 7 over 2. Now this is a property. What is this equal to?
Negative 7 over 2.
Yep. So it's log base e of e to the negative 7 over 2. If you're looking at properties, it's property 3. It's It's just written a little different.
Yeah,
If you see an ln and an e together, you know those are going to cancel.
You're messing with my brain.
Sorry.
This is quick on the yeast thrasher. I drank a caffeinated beverage today. I don't usually.
Love that.
So the day we're not
But
supposed
they were
to
not
drink
supposed to drink
caffeine.
caffeine, actually. No, I did it too.
We all drank caffeine.
I got used to it.
Yeah, I drank the doctor.
And like no milk or anything.
Yeah, no. I didn't have dairy, but I had caffeine.
I had a
Alright.
cheeseburger last night.
5 raised to the log base 5 of 8. This is
Oh, that's a property.
Oh, I know that one. That one's easy to point out.
what is it?
Okay,
8.
8.
yeah, it's 8 because it equals rest.
Yeah.
Now, if you were to forget that, I'm gonna back it up.
Which might possibly.
So this equal to x. So log base 5 of x is equal to the log base 5 of 8. Okay.
So you just
Log base 5 of x is equal to whatever this last thing up here is. So then, because these have the same log or the same base, x is equal to 8. So if you forget the property, that's what it would be. 22. 10 raised to the log of 14.
So then
Well,
it would
then-
just be 14.
Yep.
Because it's log base 10, right?
Yep. And I'll do a natural log one. E to the ln of 1 over 5.
One over 5.
Yep. All right. All right. I don't think this was written in your notes, so you need to write this. You can't have a negative.
Oh, it was. Yeah.
It was.
Yeah.
Or 0
Oh, yeah, that was right.
inside the log. Okay. So
Same color too.
Inside.
inside the log, so you can't have like the log of negative 5.
Oh.
Basically, it's undefined if that happens. So these next ones are using your calculator. Okay. The difference of if you're going to be using your calculator or not is if there's decimals in there. If they're numbers like these that you should be able to solve, you cannot use your calculator. Okay. But these ones like this, 26 log of 0.908. And they're all either going to be log base 10 or ln, so you don't have to worry about trying to put in the... So you would just hit the log button on your calculator and then 0.908, and then whatever that's equal to is what you write down.
Log. Oh, that's nasty.
What'd you get?
I got negative 0.04.
Okay. The negative in the answer is fine, it just can't exist inside the log.
And if it exists inside the log, it's undefined.
Yes. So, like this one, the log of negative 5.14, you would just say is undefined. Okay, because of this rule that's up here. And then the last one, last one of the calculator ones, ln of 0.733. So this is the ln button, obviously, instead of the log button. Did you get?
Negative 0.311.
Yep. And then just so you see one of these, 36 log of x is equal to -3. And we're trying to solve this. So this is a log base what?
Log base 10.
So you have 10 to the -3 is equal to x. 10 to the -3 would be what?
No. Well, wouldn't you have to flip it?
Yeah.
So it'd be 1 over 10 cubed, which is what? 1 over.
1,000.
Yep. Okay, so your problems are 1 through 35, every other odd.